Hi there, mathematicians. It's Miss Johnson, and today we're going to be looking at qualitative probability. And that's just a big word to mean we're looking at like comparing the probabilities with each other. So, like, is a probability impossible, unlikely, equally likely, or in even chance, likely, certain? So, we're kind of comparing the probabilities. All right, so let's just go ahead and get started with some questions. All right, so number one says a bag contains 14 blue marbles and 14 purple marbles. What is the likelihood of randomly drawing a purple marble? Okay, so we go back and we look at what we have. So we have 14 purple marbles, but we also have 14 blue marbles. So if you're randomly selecting, it's exactly the same number of marbles of each color, right? So that means that it is equally as likely, okay? It would be right here in the middle, the even chance. Okay, right here in the middle. The even chance. Either one could happen just as easily as the other. So it would be equally as likely. Now, unfortunately, not all the questions are going to be that easy. Now, let's go ahead and look at number 2 and see how they changed it up a little bit here. It says the probability of selecting a prime number from a bag that contains the numbers 2, 3, 4, 5, 6, and 7 is 2 to 3. Which statement is true? Okay, so as we peruse through the answer choices, it says you are more likely to select a prime number than a composite number from the bag. You are twice as likely to select a composite number than a prime number. A prime number will always be chosen on the third. Oh, we can already cross that one out. A prime number is not always going to be chosen, right? Not all of the numbers in there are prime. And we know that because this right here is not 3 over 3. Because 3 over 3 would mean it's certain to happen. All right, so we know that's not true. D says you are less likely to select a prime than a composite. Okay, so even if you don't remember what prime and composite are, that's okay. You don't really need to know it to answer this question, right? It tells us what the probability for getting the prime number is. So the probability of the prime is 2/3. So using what we know about complements and what we've learned about the complement, we would know that the probability of pulling a composite number, so 2/3 plus what will give us 3/3? Will be 1/3. Right? 2/3 plus 1/3 is 3/3. So the original probability that we want and the probability that the other probability have to add together to be 1. Okay, so we know it's 2/3 and the probability given in composite is 1/3. So even if you don't remember the definitions, because they give us that it's 2/3, we can still answer the question. All right, so you are more likely to select a prime number than a composite number from the bag. So this is A. You are more likely to select a prime than a composite. So look here for the prime is 2/3 and composite is only 1/3. So are you more likely to select the prime? Yeah, because you have 2/3 of a chance. So we're going to put a true by this one. We're pretty sure that's the answer, but let's check the other ones to make sure. You always want to check because sometimes these ones with all the words can be a little bit confusing. So you are twice as likely to select a composite number than a prime. Twice as likely to select a composite. Well, composite is smaller, so are you twice as likely to get the composite? Actually, you're twice as likely to get the prime. Okay? It's backwards. So this one is false. And then we already proved that C was wrong. False. And then D says you are less likely to select a prime. No, we're not less likely because the prime is 2/3 and the composite's only 1/3. So D is also false. A lot of kids get scared when they see the questions, the answer choices with all the words, but sometimes they're the easiest questions. So just read it, take your time, read it, pull out what you know and figure it out. You can do it. All right, number 3 is another one that's kind of wordy, but let's not worry. We can get it. So Jesse has 20 drawings in his sketchbook. Of these drawings, 6 drawings have musical instruments, 12 drawings have animals, and 2 drawings have buildings. There were also people in a third of the drawings with musical instruments and 2/3 of the drawings with animals. None of the building drawings included people. Based on this information, which statement is true? All right, so it says the probability of randomly selecting a drawing that has a building in it is 2%. All right, let me tell you something about these questions. You're going to have to do every single answer choice because they're tricky, right? And whenever you see that word true or correct or accurate, you need to go through each one, okay? Put T's and F's. All right, so let's do them one by one. So probability of randomly selecting a drawing that has a building in it is 2%. Okay, so let's go back and see what they tell us about the buildings. All right, buildings right here. It says 2 drawings have buildings. All right, so 2% is 2 over 100, 2 per 100. So is 2 drawings have buildings? Is that equal to 2 per 100? How many sketches were in his book? 20 drawings, right? So this is really 2 per 20 is what he really has. So are those equal? Nope. So this one is false. All right, let's look at B. B says the probability of randomly selecting a drawing that has people in it is greater than the probability of randomly selecting a drawing that doesn't have people in it. Okay, so that's a lot of words, but basically what we need to focus on is the probability of selecting a drawing that has people in it and then that doesn't have people in it. So those are the complements of each other, right? So if we figure out one, we can get the other one real easy. Don't forget that word random right there just means you're not looking, you're just picking it, and you're not like looking at them first and picking the one that you want. So it's just random. Okay? All right, so let's go back and let's figure out the stuff about the people. All right, so right here it tells us that 1/3 of the drawings with musical instruments have people and 2/3 of the drawings with animals have people. All right, so let's figure out how many that actually is. Okay, so 1/3 of, remember, of in math means what? Means multiply. So 1/3 of the drawings with musical instruments. So how many have musical instruments? 6. 6 drawings have musical instruments. So we're finding 1/3 of 6. So 1/3 times 6 is going to be 6 over 3, which is 6 divided by 3 is 2. And we're going to forget what that was for. So this is 2 people and musical instruments. Okay, I'm going to change colors for the next one. Then 2/3 of the drawings with animals have people. So how many drawings have animals? 12. So we're doing 2/3 of 12. Well, I should just put the multiply sign. Remember that of means to multiply when it's right next to the fraction. So 2/3 times 12 is going to be 24 over 3, which is 8. So 8 people and animals. Okay, so let's go back to B. All right, B says the probability of selecting a drawing that has people is greater than doesn't have people. Okay. All right, so how many drawings have people? So 2 people, 8 people. So 2 plus 8 is 10. So 10 drawings have people. So how many don't have people? Well, there's 20 drawings, right? So 20 minus 10, running out of room. 20 minus 10 is 10, so 10 don't. So is the probability going to be greater than if 10 drawings have people and 10 don't? No, it's going to be equally as likely, right? It's exactly the same probability. So this is going to be false. All right. Whew, that was a lot of work for that one. That's okay. It wasn't hard work, right? Just a lot of work. All right. The probability of randomly selecting a drawing that has animals in it is 6 times the probability of randomly selecting a drawing that has musical instruments with people. Okay, so we got to figure out the probability of selecting something that has the animals in it. So there's 12 animals out of how many? Out of 20. So 12 out of 20. And it says is 6 times the probability is 6 times. So 6 times the probability of randomly selecting musical instruments with people. All right, so here it is. Musical instruments with people is right here, right? 2 people plus musical instruments. Do you see the importance of a labeling, right? I knew that it was 2 people with musical instruments because I labeled it. All right, so make sure you label your answers. All right, so 2 out of what? 2 out of 20. 2 out of 20. So is 2 20ths times 6 going to give us 12 20ths, right? So it's going to be 6 over 1 times 2 over 20, and that gives us 12 20ths. So this one is true. We always check all the answer choices for these because we could accidentally get confused. All right, so the probability of randomly selecting a drawing that doesn't have people in it is 10%. All right, so we figured out how many people don't have people in it already, and it is right here. So 10 don't have people in it. But remember, this is 10%. That's 10 per 100. But he didn't do 100 drawings. He did 10 don't have people in it out of how many drawings? Out of 20, which those are not equal. So this is false. So our answer is C. So sometimes these qualitative probability questions, there's a lot of work to do in them, but it's worth it to get the right answer and work through it. Okay, and some of them are pretty easy, right? Some of them might be a little bit harder, but if they're a little bit harder, that's okay. You just keep working through it and keep doing it. All right, let's look at 4. All right, why don't you pause the video and try to answer number 4 by yourself? Pause the video, try to answer number 4 by yourself, and then after you answer it, unpause the video and listen to the explanation. All right, Jana has 2 boxes, chocolates. Each box contains 11 chocolates filled with nuts. So box L has 24, box M has 12, and it's with 11 with nuts. And this one also has 11 with nuts. So when I look at this one, right, box M, it has 11 with nuts in it out of 12. So if I'm picking something from box M, I'm pretty sure it's going to it's almost definitely going to have nuts in it, right? All right. I don't know if that's going to have anything to do with the answer choices. Let's go find out. All right. So A says the probability of randomly selected chocolate filled with nuts from box M is less than the probability of randomly selecting a chocolate filled with nuts from box L. Okay, well that's not going to be true because box M is almost all chocolates, right? Box M is 11 out of 12, and box L would be 11 out of 24. So it's not less likely, it's more likely, right? So this one's false. B says the probability of randomly selecting a chocolate filled with nuts from box M is 1. Well, it's not 1. It's super close to 1, but it's not 1 because it's only 11 out of the 12, not all of them. So this is false. And let me put because it's 11/12. All right, C. The probability of randomly selected chocolate filled with nuts from box M is more than the probability of randomly selected chocolate filled with nuts from box L. We already figured that out. That's going to be true because this one is box M is 11 out of 12 and box L is 11 out of 24. So 11, 12, you're definitely more likely to get it out of box M than a box L. So this one's true. We're checking D just to make sure we didn't mess up, right? All right, so the probability of randomly select chocolate filled with nuts from box L is equal to the probability of box M. No, 11 twelfths. 11 out of 12 is not equal to 11 out of 24. So this would be false. So our answer is C. So you see, this one was a lot easier than number 3, right? So don't be intimidated because you never know how hard it's going to be. You never know how hard it's going to be. Just work through them. All right. Number 5. Maria has a spinner, made a spinner using 5 colors. When she spins the arrow on her spinner, it is twice as likely to land on red than it is on blue. It's 3 times as likely to land on red as it is on yellow. It is equally as likely to land on purple as on green. Which spinner is Maria's? Okay. So which ones do you think we can eliminate right away? I see one immediately. I know I can eliminate. It is not C, because this twice as likely and 3 times as likely and equally as likely, these all have the same probability. These are all equally as likely. So I know, because they're the same size. So I know that this cannot be the answer. Probably B is not the answer either, because twice as likely and 3 times as likely. So I'm crossing B out. All right, so the first thing I would look for is the easiest thing. So which one do you think would be the easiest to find? Okay, well, I think the easiest to find would be this one. I would do this one first because it's equally as likely. So purple and green, if they're equally as likely, that means they have to be the same size. So I'm going to go look for a purple and green that are the same size. Nope. So A is probably not correct, but look at that. Look at this one. Green and purple the same size. So I'm thinking D is going to be my answer. I'm pretty sure. Pretty sure A is not going to be. But let's check these other ones. So the first one says it's twice as likely to land on red as blue. So that means red is bigger than blue. 3 times as likely to land on red than as on yellow. So that means yellow's got to be the smaller one, which it is in D, it's smaller, and then blue. And it's twice as likely. So this is a quarter, right? And so red would have 2 times. So D is definitely correct. Okay, so do you see how we kind of, on these, definitely use elimination to eliminate the answer choices that you know can't be. Okay? All right. And that is qualitative probability. I don't think you're going to have to remember that word qualitative, but it's just which one is more likely. It's getting you to compare the probabilities.